Okay, so I was explaining to say there was a mistake there. This is 128 minus 1. It's supposed to be 127. Then we multiply by 2. That should be 254, not 252 as I earlier wrote it. Okay, so therefore, this is our moment about the y-axis. Okay, let's pick the next one, and I hope we can be quick.
Sir, your mic is muted.
Oh, goodness. So I've been wasting my energy all along.
Sorry, me, I thought maybe you were just doing some other thing.
Oh, this is sad. So, you guys let me waste my energy all along.
We thought as though you were doing something else, since at first you were talking to someone.
Oh, not really. I didn't notice that. Okay, so I was trying to explain to say, to find the moment about the x-axis, the formula is that we need y squared multiplied by some line x equal to L of y. But again, in our region, we notice that when we make the horizontal line L of y, as it is moving up and down, it changes to hit from this x equal to 2 to 0 to hitting x equal to 2 to some curve here. Immediately it crosses y equal to 1. So that's why I said again, we need to have two different lines. Okay, and then we said, okay, let's find this first line, L of y1, okay, which is simply going to be 2 minus 0, because this is x equal to 0, and that will just be 2. Okay, then L2 of y is going to be some x2 minus x1. In this case, x2 remains to be 2, and x1 is going to come from this curve. So we make x subject from that. Okay, so I'll leave this as x1, where y equal to e to the power x. So how do we make x subject? We know that x is a power in that case, so we can introduce logarithms. So to the base of e, so when I introduce logarithm to the base of e, then that's simply ln. So I introduce ln both sides, I'll have ln ex. Okay, so we see that this will mean ln of y, that will drop. So we'll have x ln of e. So ln of y will simply be, this value is 1, it will simply be x. Okay, so, and this is what I want to call as my x1. So my x1 is ln of y. So L2 of y is 2 minus ln of y. Okay, so we come back to our function, our formula. So therefore we replace now to say that will be 0 to 1, y squared by 2, that would be 2y squared dy plus, then I multiply y squared to this, I'll have the integral from 0 to e squared, 2 minus ln of y multiplied by, so if I choose to bring the y squared this side, then dy. So maybe the only part where you need to think is here. This is an polynomial which is very easy to integrate. Okay, so we need to now, what method do you think we can use here? Okay, so we are going to use integration by parts. No one answered. I thought someone would answer. So we see that we have a function, a logarithm, and some algebra. So we're going to use integration by parts. Yeah. Okay, so to evaluate 2 minus ln of y by y squared dy. So simply we are going to let. So using integration by parts, we know that logarithms will be the first. So if you follow that Yoliate, so we let therefore u equal to ln of I pick everything there, so that would be 2 minus ln of y is what is equated to u in this case, right? And then therefore our dv is whatever remains. So dv becomes y squared dy. Okay. From this I get that du is going to be, so what is the derivative of ln of y with a negative? That will be negative 1 over y dy. So I'm differentiating implicitly here. So I differentiate u, I get du, I differentiate that, I get that. Okay, so to get v, I have to integrate. So integral of dv will be the integral of y squared dy. So here I get v equal to y to the 3 over 3. So here I don't add a constant of integration yet. Okay, from this, it follows that now the integral of 2 minus ln of y squared dy has become the integral u dv. And then we say this is uv minus the integral v du. Okay, what is our u? Is that one. Our v is that one. So I can even start with v. Y to the 3 divided by 3. Then I bring u minus the integral v is y to the 3 over 3. I bring du. That would be now negative 1 over y dy. Okay, so we have y to the 3, 2 minus ln of y. So a negative by negative, that would be plus. Then I can always bring out the 1 out of 3 outside. Y into y to the 3 is y squared dy. So we have 2 minus ln of y, 1 over 3. So again, we know the integral of y squared is y to the 3 over 3. It's this time when we can add a constant of integration. Okay, so but what we want to do is actually evaluate the definite integral there. So when I place everything back, therefore, moment about x-axis is equal to, so we integrate that, that will be 2 over 3 y to the power 3, evaluated from 0 to 1. And then this part, I bring what I had. Okay. So what we had is this one here. So we bring that y to the 3. Actually, I can factor out the 3, 1 over 3. So that we'll have 2 minus ln of y. This side will have plus y to the 3 over 3. We evaluate this from 0 to e squared. What we have is, we evaluate this part, we'll get 2 over 3 plus, so when y is e squared, in this case we'll have e squared to the power 3 is going to be e to the power 6, right, over 3. And then we'll have 2 minus ln of e squared. Okay, and then we'll have plus, again, y to the power 3, in this case is e to the power 6, divided by 3, minus the lower limit. When you plug in 0 there, well, everything becomes 0, because when I put 0 here, then I'm multiplying everything by 0, so I don't bother. Okay, so I end here plus 0 if you like. So this will be 2 over 3 plus e to the 6 over 3. 2 minus, I know that here using rules of logarithms, I drop the 2, that would be 2 ln of e, but ln of e is 1, so I remain with 2 plus e to the 6 over 3. Okay, these here they cancel. So actually what we have is the square of e to the power 6 over 3. So when we do the square there, we'll have 2 over 3 plus e to the power 12 over 9. Okay, so that will be the moment about the x-axis. Do you have questions? Okay, let's find the moment about the x-axis. So again, we're using this our graph. So what we haven't found is h of x. So maybe if I do my horizontal line here, which I want to call y equal to h of x. Okay, you see in this case that it is going to be hitting this x-axis and that curve each time as it is moving in that direction and in that direction to finish the whole region. So this strip is going to be moving like that, but at each point it is hitting this x-axis and that curve. Okay. So from that, clearly, we say h of x is simply equal to y2 minus y1, but y1 is the line y equal to 0, so this is just y2. In that case, y2 is the graph e to the power x. Okay, therefore, moment about y-axis is going to be, of course, again here our x, we can see that it is moving from 0 to 2. So therefore, moment about the y-axis becomes the integral from 0 to 2 x squared, then h of x in this case is e to the x dx. Okay, what method do we use to integrate that? Hello?
Integration by parts.
Exactly, again, we use by parts. So in this case, you are seeing an exponential and an algebra. So when you use that Yoliate, you're saying what comes first is actually an algebra before an exponential. So in this case, you let u equal to x squared and dv equal to ex. In this case, du becomes 2x dx. Then v, of course, the integral. You're doing a reverse. If you do the integral, then you get back to v. Then the integral of that is a special function. It will be the same thing. Okay. Then this implies that now to evaluate the integral, here I can go right away with the limits. So that's too easy. Ex dx will be the integral from, if you like, so I can still maintain 0 to 2 of u dv. Okay. And then what we have, this becomes uv minus, what is that? That would be the integral v du. Of course, we are getting, but of course, these limits are not appropriate to use in this case because I'm changing the variables, but I can still maintain those. for now. Okay, then when you replace, we'll get our u is x squared, our v is ex, so we'll have x squared ex minus the integral v is ex from 0 to 2, and then du is simply 2x dx, so I can remove the 2 this side, so that I have x dx. So you may wish to rewrite this as x squared e to the x minus 2 integral 0 to 2 x ex dx. Okay. Again, you need to do a repeated by parts integral, right? So again, here we see that we can't integrate that, we need by parts. So for the part where we are doing that, again, that would be equal to, can I go direct and say uv? Okay, our u in this case is x. Our v will remain the same thing, minus the integral v is the same thing. Okay, ex from 0 to 2. And then we see that the du, when I differentiate x, I get dx. Okay, I don't want to write the formula since we have already seen what's happening. So ex minus, this will, now the integral of that is surely just ex from 0 to 2. Okay, so let's get back to our moment about y-axis. Then remember we left it here. Okay, so that will be x squared ex minus 2. So I had a minus 2 here, then whatever I got, I'm going to multiply by minus 2. So that's the part where we have x ex minus ex. Then we evaluate this from 0 to 2. Okay, so when we evaluate, we put 2 there. Wherever there is x, we'll get 4e squared minus 2. We put a 2 here and a 2 there, that would be 2e squared. Okay. I put a 2 here, that will be minus e squared. Okay, then I subtract the lower limit. So I see that the lower limit is a 0. So when I put a 0 here, this everything becomes 0. I put a 0 here, this is a 0. So I'll just consider negative 2 times this part. But negative by negative, that would be now plus 2 multiplied by negative 1 inside. Right? So we'll have 4e squared. When we expand, that will be minus 4e squared plus 2e squared minus 2. Okay. So our value therefore is 2e squared minus 2. If you like, you would say this is e squared minus 1. So that would be the moment about the y-axis. Okay. Do you have questions?
On the plus 2, it's supposed to be the negative one has just has to be 1.
Which part is that?
Because e to the power 0 is 1.
Mm-hmm.
Then you've written negative 1 and you've written plus 2.
You mean here?
Yes.
I don't think there's anything wrong because look, I'm taking the upper limit. Upper limit will end here, right?
Yes, it's ended
Then
there.
I subtract the lower limit, but
This will
the
be
outside
0.
part has a negative. So when I introduce the negative, another negative, that will be plus. plus 2. But here already, this is a -1.
Oh, okay, okay, I get it. Okay. I
Alright.
thought as though you were multiplying with the one inside.
Okay. So maybe if we have time, let me see, we have 10 more minutes. Let's pick a question from an exam and see if we can be able to maybe finish one part. Okay, so here it is. So this was the exam for last year. So you have find the moment of inertia about the x-axis of the finite region bounded by the curve y equal to the root of x minus 1, the x-axis and the line x equal to 5. Okay, so I want to be quick on that one. So we have very few minutes. I don't think we'll finish it. But the whole thing, you just need to understand that, look, this is a graph that you've been sketching in first year radical functions. So we'll not waste time to sketch that. Just sketch it right away. So what that means is this graph is the root of x shifted to the 1 unit, right? So meaning it will start from this side, right? So it will start from -1. No, not -1. It's actually shifted to the right. What am I saying? So it is shifted 1 unit to the right. Okay, so that would be the graph. Y equal to the root of x minus 1. Okay, so the other thing we're considering is the x-axis. So the x-axis is right here. And then we also want to consider the line x equal to 5. So let's say x equal to 5 there. So therefore, the region we're considering is that one. So I want to find the moment about x-axis. So in this case, I just need to find the lines L of y. This was a very easy one. So we'll be considering when x is 5 there. So you notice that when x is 5, that would be the root of 4. So we'll be talking of 2 there. So from 0 to 2. So this coordinate is 5, 2. Okay, so when we make our line, a strip which is horizontal, so you notice that this strip is what we are calling x equal to some L of y. So it will be moving up and down. So that's why it was important to know that part. So it is moving actually from 0 to 2. Okay, so let's find what is our L of y there. It will be some x2 minus x1. In this case, x2 is 5. And then x1 is from that curve, look. So if I choose my strip to be there, it is hitting the same end this side, and it's also hitting that curve. So I need to make x subject from there. So I'll leave that as x1. So y equal to the root of x minus 1 implies that we square both sides, we'll have y squared equal to x minus 1. Therefore, x is 1 plus y squared. And this is what we are calling our x1. Therefore, L of y is 5 minus that. So, of course, that would be simply 4 minus y squared, right? When we subtract. And we know now that our moment about the x-axis will be the integral Okay, from C to D, y squared, L of y dy. So we see that this our strip is moving from 0 to 1 along y. So that is C is 0, D is 2. Y squared, L of y is 4 minus y squared.
Sir, your mic.
All right, I had the disruption. So when you expand there, we see that you're just talking of 0 to 2, the integral 4y squared minus y to the 4th dy. Okay, so when you integrate there, what are you getting? Okay, that's 4 out of 3 y to the 3 minus 1 out of 5 y to the 5 from 0 to 2. Okay, what are you getting? When you put 2 there, you have 8. 8 by 4, that will be 32. Divide 3 minus, you put 2 there, that will be 2 to the power 5. That's another 32, I think. Divide 5. You see that when you put 0, everything becomes 0, so that will be your only result. So common denominator is 15 there, so we are talking of 5 by that. So I can say 5 by 32 minus 3 by 32, divide 3 by 5. Okay, so that I can factor out 32 there, and I'll have 5 minus 3. So that will be 2 by 32, you've seen. So I'm just talking of 2 by 32, which is actually 64 over 3 by 5 is 15. Okay, so that will be the moment about the x-axis. So you get your 4 marks there. Questions? So I still have about 3 minutes. If you have a question, you can ask.
I mean, it's not a question, but a concern. Are you going? I mean, yeah. I'm asking for the same posted. Last time I had but it wasn't.
Try to speak up. I can get you.
Okay, I'm talking about the video because my network is tripping. So if you can send the video as soon as possible, then it will help me.
Okay, we'll try to do what's possible to have you get access of the video soon. All right, when we end here, guys. I don't know when we are meeting next, but we can always refer to the timetable. Okay, so next time we meet, we want to do some revision on from chapter 1 to chapter up to where we are, because you know that this was the last subtopic on integral calculus. So we're supposed to start vector analysis. So before we go to that, I would want you to prepare your questions on conic sections, differential calculus, and integral calculus. So next time we're meeting, I think that's Wednesday, we can start our revisions. Okay, a good evening.